Hello, ladies and gentlemen. So today we're going to be talking about area of a sector, angular speed, and linear speed. All right, so let's see. We can get our formula sheets if you have some. We'll probably have already made them throughout the year, and use the area of a sector formula to solve this equation. All right, so let's see. A sprinkler on a golf course fairway is set to spray water over a distance of 70 feet and rotates at an angle of 120 degrees. Find the area of the fairway that will be watered. So always convert stuff into from degrees to radians. So 120 degrees is the same thing as 2 pi over 3. So make sure you know that. Okay? So here's the area. This we know it's going to be from here to here. That's 70 feet. Okay? And we know that this angle is 120 degrees, or as we already said, 2 pi over 3. Now, how to get an area of a sector? The area is 1/2 times the angle times the radius squared. Well, we know all these values. The area will be 1/2 times 2 pi over 3, and then times 70 squared. Plug and chug that into a calculator because I do not expect you to do this by hand. And that will be 5,131 plus, 0.27 feet squared. Don't forget units. Okay, that's important. So this is the exact area that will be watered. Okay. Next one. The second hand on the clock is 10.2 centimeters long. So nice to know. Label. This is 10.2 centimeters long. Okay. Find the linear speed and then the angular speed of the tip of this second hand as it passes around the clock face. So linear speed, its formula is pretty simple. Okay. All right. Linear speed and then angular speed. Sorry. So for angular speed, that's the one we want to figure out first. So angular speed is essentially the theta, so the angle times time, which is pretty simple. Theta is just 2 pi, so I want to figure out exactly how fast this goes around. Well, 2 pi is a full revolution, so the whole way around, divided by, and how long does it take for the second hand to get around the clock? 60 seconds. So then this would be pi over 30 seconds, but that means nothing to us. So this is approximately, if you use your calculator, 0.105 radians per second. So every second it goes 0.105 radians. Okay? So now I have the angular speed. Now how do you get the linear speed? Okay? The linear speed is essentially the angular speed. Okay, so the angular speed times the radius. That should be little r, times the radius. So it's essentially what we got up here, that times the radius, which we already know. So it's pi over 30 seconds times the radius is 10.2, which equals, now we can use a calculator for that. So 10.2 pi centimeters over 30 seconds. That ends up approximately 1.068 centimeters per second. Okay, that's how fast the hand is moving as linear. Okay, directly that way, not around. Okay, so the math is easy. You just got to remember what everything means. So we'll do 2 more examples, and then you guys will be in charge of the rear page. Okay, so a carousel with a 50-foot diameter makes 4 revolutions per minute. Find the angular speed of the carousel in radians per minute and the linear speed of the platform rim of the carousel. Okay, so first things first, angular speed. That is, like we said before, the angle over time. So that's 4 times 2 pi, because that's a full revolution, over 1 minute, because they told us that. Over 1 minute. So that is about 8 pi per minute. Okay, which is approximately, if you use your calculator, 25.132 radians per minute. Okay. Next, we get linear speed. So the linear speed, like we said before, is your angular speed times your radius. So we already have that. Angular speed is 25.132. times, and then our radius, they told us, well, the diameter was 50 feet. Well, half of that is your radius, so times 25. Okay, so now if it's 25 times 132 times 25, that gives us 628.318 feet per minute. Okay, everybody clear? Okay, moving on. So finally, a car's rear windshield wiper rotates through a 125-degree angle. So we can even draw what's going on. So we know that this car just kind of does this at 125 degrees. The wiper blade is 7 inches in length, so 7 inches. Find the area covered by the wiper and the arc length of the distance traveled by the tip of the blade as it sweeps across the shield. Okay, so easy. Arc length. Again, from our formula sheet, that distance is r theta. So r times theta. Well, we already know that the radius is 7 and the angle is, what's it called? 125 degrees, but we can convert that into radians. So let's do that real quick. I'll do that in blue. So 125 degrees times pi over 180, right? That is roughly 25 pi. Again, you can use your calculator to simplify this. 25 pi over 36. So now we can actually convert this. So that would be, that length is 25 pi over 36 times 7. That simplifies to approximately 15.272 inches. Okay, now to get the area, well, we have our arc length, and area is honestly just 1/2 times the, what's it called? Times the angle. So 25 over 36, don't forget pi, and then times the radius squared. So we have arc length done. After we plug all this into a calculator, this is approximately 53.451 inches squared. Okay, and so there we go. We figured out our arc length, which was this distance right here. Okay, arc length was that distance. And then the area was the whole area, of course. You guys will be in charge of the next page. Good luck, and I will be here to help you tomorrow. Have yourselves a wonderful evening. Goodbye.